So, stepper motors, in particular bipolar stepper motors. I mentioned it briefly in episode 12, a little bit of a difference between unipolar and bipolar. They've only got 4 wires on bipolar, and it is basically, it relies on the fact that these circuits can go in either direction, so it can be plus and minus or plus and minus, and they're reversed by an H bridge on the motor driver on the Genie 18 motor board. So what you can do here, those of you that aren't in our college, you might be able to find the sample circuits here. However, we find them on S drive. Let's see, student share, where is it, that one there, and then design technology, circuit wizard sample files and resources, and you should scroll down to various stepper motor ones. Where are we here? Stepper. Okay, I'll have a look at reversing a stepper motor, and I'll look at the flowchart one here rather than basic. So it opens up at some point, and we've got our circuit here. Now if we simulate that, you'll see we've got a simple circuit. One input switches it on and off, and the other one goes forward and reverse. Now notice, I mentioned before in the introduction as well, generally if you find a 4-wire, 4-pole stepper motor with a black, brown, orange and yellow wire, then you can assume it to be the right kind of one. It should have the same step sequence. It should work straight away using this program, assuming it is a 5-volt one as well, if we just plug it straight into there and use 4 AAs. If you just find any old stepper motor and you've got 4 different coloured wires, the first thing to do is to make sure, because we've got 2 coils, it's important to know which wire corresponds, or which pair corresponds to which coil. So there's 2 ways of doing that. You can either get a voltmeter and measure the resistance between, well, just try any old 2 wires, and if they're a pair like these 2, you should get a few ohms. Whereas if they're not a pair, so if it's that one and that one, it will be open circuit. Okay, so that's an easy-ish way of doing it. An easier way, although it can depend on the strength of the stepper motor, is to touch these 2 wires together when you've got the 4 wires all loose. If you pair up 2 wires and then just turn the rotor, if it's harder to turn when you've got the wires touching each other, they are a pair for a coil and they're a pair. So there's 2 methods of just detecting which coil corresponds. It won't work at all if you wire up opposing wires, so this one and this one on this output here. But the other thing to bear in mind, if we look on the flowchart here, is an example here of a step sequence. Now I've just imported this one that works fine with these coloured wires, but you'll find if you go on Google and you type in a certain type of stepper motor, if you just type step sequence, you'll probably get some dancing thing, but if I put bipolar stepper, I haven't got one to hand, I should run maybe, but we'll find, let's see now, you'll find each turn has a different pulse depending on what kind of sequence there are. And there are also different types of sequences, so you can have a full step sequence for faster turning, and then a half step sequence for more precision, so more accuracy in how far it turns. I can't imagine many of you will be programming your own stepper motors. Some of you might do. It can be a bit of a fiddle, it doesn't always work, but I find if you use the ones built into Circuit Wizard and use this standard step sequence, so if you notice here, I'll click on the stepper motor function, which is just the motor function with stepper chosen, and then you'll see this sequence here. Now to make it go forwards or backwards, rather than redrawing it the other way around, you just press these arrows. So that's backwards, that's forwards, and you can see it's prompted there. Now, as well as the number, this is an individual step, and then it'll pause, and then it'll go around again, and it'll just check the switches are on, and it'll do it again. Now this will happen 10 times a second with a 100 millisecond pause. If you reduce this pause, it'll go quicker. So you can control the speed of a stepper just by the pause in between each step. As well as that, you can count the amount of time it's on for, or count the amount of steps. So obviously the time will just give you a rotation amount in a time duration, whereas counting the number of steps will give you a more accurate angle at which it rotates, depending on the step type. So you might have to kind of do, say, 100 steps and see how many degrees it rotates, and then work out how many degrees per step. You might find there's an exam question like that, that kind of thing. So just because I'm a bit lazy, I'm going to just take these, I don't need to take them off here. I'm going to just change this circuit a little bit, just so it's easy to demonstrate. So I'm going to do it a few seconds. Firstly, let's just delete all of that. Right, so, oops, let's just do that. Now, I'm going to do a for loop here. Let me just draw that a bit nicer. And let's get a for loop. And I'm going to do, let's say, 3 seconds. Time delay, sorry. 3 seconds. Okay, and then I'm going to end that loop. So all it's going to do is just go round and round and round doing this forward thing. And then I'm going to copy that and paste that. And just put a backward one. I could just drop that in, or I could just double click on that and go like that. Okay, now I need to find my start button. Start, there it is. So, yeah, that just makes life a bit easier, just because I can't be bothered to wire up some switches, but let's just check that works. Forwards one way, and then back the other way. So wiring that up, nice and straightforward. We just correspond the colours of the wires on our Genie 18 motor board. Plug up the stepper motor, and it's as simple as that. As you can see, we've just got that forward and backward rotation. Just got a little bit of masking tape on there just so you can see the direction turn easier. So that's pretty straightforward. Right, now I'm going to pimp it up a little bit. I've still got quite a simple circuit design here, so I've just added an LCD screen here, and I plugged it into Q0, and this is the unamplified, so it hasn't got a transistor on it. It's just straight out of a Genie chip, the signal voltage, and then we've got our plus volts and 0 volts. Same as the servo, nice and easy to use. I've also got 3 input push-to-make switches. I've got a select up, a select down. I could even just live with a one select up button and then an enter button here. So what have we got here? And I'm going to run through it bit by bit, so it looks a bit daunting. But basically we've got 3 sections here. We've got here we've got select forward or backwards option. We've got I can't remember what this one is. So this is the time it's on for. And this one is whether it's fast or slow. And then when you've got those 3 bits of information, it runs the stepper motor depending on the criteria. Now the way it works is we've got 3 variables. A is almost like a binary variable, so we've either got 1 or 0, depending on whether it's forward or backwards. B is the time, and that can be 0 to 9 here. So B can be a variable from 0 to 9, and that is in seconds that it's on for. And then C is a bit like A, where it's just a binary option, but instead of 0 or 1, we've got the milliseconds here that it pauses for. Now, you could be clever and actually kind of do a much more detailed speed by just having some formula that gets the milliseconds, you know, more than just 2 options here. You can have any manner of options if you do a bit of maths. Anyway, let's start off. So first of all, having sent all of the stepper motor outputs to be low, just in case it comes out and it just finishes on one of them being pulsing. It might still pulse, so it's a good idea to just switch them all off. Might save energy, save power as well if you're not energizing a coil and someone walks away. So the first option is set direction, and it's going to start with forward option like that. Now D0 and D1 are the select buttons, select up. Now in this case I've only just used D0 to cycle between forward or backwards. So D2 is the enter button, that goes into the next step. Now if that's not pressed, it asks is the select button pressed. If it's not, neither of them pressed, it will just stay in this loop and it will just wait until a button is pressed. So it's assuming that I'm going to select forward. Now if I want to select backwards, I select the select button. It gives me a little bit of time just in case I hold that button down for a fraction of a second just to release the button, and then it's going to ask if I want reverse. Now if I don't want reverse and I select it going back to forwards, it will come back here and do forwards. So this cycle here selects between forwards and reverse depending on whether the select button is pressed. At any point I press the enter button, I come out of that and that variable gets assigned. So forwards is going to be 1 and reverse is going to be 0. Now these both go up here, but I've also got a question to see if the enter button's been released, because I found if you didn't have that, it will just go straight through it. If you're holding the button down, you want to check that someone's let go of the button before the next thing, just in case they accidentally select the time they don't want. So this is going to have time, and this time there's a variable actually going to be set into the LCD here. So this variable is currently nothing. But every time I press D0, I add a value to it. So this number of seconds goes up. And every time I press 1, the value goes down, it decrements. Now if it starts at 0 and I press decrement, so select down, it would go to 255. It goes around the clock like that. So to stop it doing that, I'm asking if it's above 9, just make it 0. So that's what this question is. If the value of B is above 9, so if I've gone up 9 or 10, if I press the up button 10 times, rather than going to 11, it'll just go back to 0. And then if I press the down below 0 and it says 255, that's also above 9, so it'll just make it 0 as well. It just neatens it up a little bit. And this will keep going round this way, these two up-down options, until I'm happy with it and I press D2 to enter. Again, I've got to check to see I've released D2 so it doesn't carry on onto the high-low thing. And this is the same fashion as this. So is it high? Have I pressed the select button? If I haven't, have I pressed the change button? Sorry, the enter button that was. If I haven't, have I pressed the select button? And if I have, then it asks if I want low. And if I carry on pressing select, it goes back to high, high to low, depending on that, until you press enter and you come out of it. So when it's entered high, we've only got 50 millisecond pause, so it's a smaller pause than the slow speed at 200 milliseconds. And then the program runs. So we've got a question that checks what A is. So if it is forward, A is 1, we go down this route. And if it's backwards, A is 0, we go down this route. That's everything else. And they say the only other option we can have is 0. Here we've got just a little indicator message saying it's running forwards. This is the for loop. So this is like a repeating loop like we used in the last example for amount of seconds. And that is just the amount of seconds that we've set on that variable, B. Okay, and then the pause are these variables, C's, so it can either be 50 or 200. Now, remember, you could use something like that for the speed by incrementing or decrementing C, and then you times it by 10 or something like that. Obviously, if you increment it, it will make it slower because you're getting a longer pause, so you might want to kind of inverse that by some kind of simple formula. And that's pretty much it. It's a nice simple menu system. Well, it doesn't look that simple. Hopefully it's not too complicated. And yeah, let's see it running. So as you can see, we've got the 3 buttons selecting up and down. Like I said, we didn't actually have to have the middle down button because you can cycle up through 0 to 9 on the duration time. And then you can cycle yes or no, so forward or backwards, high or low, no problem like that. And then when you press enter, you've got you've got whatever duration, speed and direction that you've chosen on that one. Now notice as well, when I'm running on the battery, you find the LCD might not go as strong. It might not have as much power to run both the motor and the LCD at the same time. But yeah, give yourself some fresh batteries, it might be better. So you can see here, forward, reverse, set the time, up or down. Let's go up to 3 seconds, and then let's have high speed. So yeah, 3 seconds, going around that way, high speed. Now excuse my arm, it's in the way, but yeah, let's try it in reverse, low speed, and I can't remember what it said, 2 seconds or something. There you go, slow speed the other way. There you have it. Hope that was useful, and see you in the next one.